Road to Olympiad.
Welcome to RTO. Consider the following problem. Find the minimum value of m plus n where m and n are positive integers satisfying 2023 divides m plus 2025n and 2025 divides m plus 2023n. Divisibility is fun. We see two relatively prime numbers, 2023 and 2025 here. Also, not to mention that both of them have m, which is invariant in this case. How are we going to relate them together to find the minimum value of m plus n? Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that given the fact 2023 divides m plus 2025n, it is equivalent to say that 2023 divides m plus 2n, which gives us m plus 2n is equal to 2023x for some positive integers x. Similarly, 2025 divides m plus 2023n is equivalent to 2025 divides m minus 2n, which gives us m minus 2n is equal to 2025y for some positive integer y. Subtracting the two equations gives us 2023x minus 2025y is equal to 4n. Taking congruent modulo 4 and do some slight rearrangement, we have y is equal to 3x mod 4. Now, notice that m minus 2n is definitely less than m plus 2n, due to the fact that both m and n are positive. Also, m minus 2n must be greater than negative m minus 2n for the same reason, which negative m minus 2n is equal to negative of m plus 2n. With this, we can slowly work out to find the value of m and n that satisfy the given conditions. If x is equal to 1, we have m plus 2n is equal to 2023. This gives us m minus 2n is between negative 2023 and 2023. As a multiple of 2025, the only possible value for m minus 2n is 0. But this gives us y is equal to 0, which does not satisfy the fact that y is equal to 3x mod 4. If x is equal to 2, we have m plus 2n is equal to 4046. By the similar argument, we can find out that m minus 2n must be negative 2025, 0 or 2025, which correspond to the value of y, negative 1, 0 or 1. But for x is equal to 2, y must be equal to 2 mod 4 as well. So again, we have no solutions here. If x is equal to 3, we have m plus 2n is equal to 6069. Again, we have m minus 2n is equal to negative 4050, negative 2025, 0, 2025 or 4050, corresponding to y is equal to negative 2, negative 1, 0, 1 and 2. Since x is equal to 3, y must be equal to 1 mod 4. So the only possible solutions here is y is equal to 1. With this, we have m plus 2n is equal to 6069 and m minus 2n is 2025. Solving the simultaneous equations give us m is equal to 4047 and n is equal to 1011, and thus we have that m plus n is equal to 5058. Now we want to claim that 5058 is the minimum. We assume to the contrary that there exists smaller sum that is less than 5058. Then the sum 2023x plus 2025y, which is equal to 2m, is less than 2m plus 2n since n is positive, which is 2 times m plus n. So it must be also less than 2 times 5058, which is equal to 10,116. This gives us a bound to the value of x and y, as in x must be less than 6 and y must be less than 5. Checking again with the fact that y must be equal to 3x mod 4, we have the order pair x and y must be sum of the following. However, some simple computations show that 1, 3 and 2, 2 will give us 2023x less than 2025y, which is not possible since m and n are positive, and thus 2023x must be greater than 2025y. Also, 4, 4 and 5, 3 is not possible because they give us 2023x plus 2025y to be greater than 10,116. So the only pair that may give us smaller sum is x is equal to 3 and y is equal to 1. But this is what we found just now, and the sum is exactly 5058. In other words, there's no smaller sum than 5058, therefore the minimum value of m plus n must be 5058. And this marks the end of our solution. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.